everybody. Today's lecture is going to be on electrostatic phenomena. But before we get into those, we need to talk about net charge, because I realize this is something that we're going to have to understand, because we're going to kind of talk about it in the context of some phenomena that we discuss. So net charge, when we use the word net in science and in math, we're not referring to a physical net. We're referring to the total or sum of something. So you might hear this in like net force, or in economics like net worth. And when we say net charge, we mean the sum of all charges in an object or system. So if you take a look right here, we've got an object or system. Sorry, I should back up. An object or system is anything that has a charge and we say isn't connected to anything else. So you might say your body is an object or a system. Because you can have a charge, right? Or the balloon that you rub on your hair is an object now with a negative charge, or a system with a negative charge. So that's kind of arbitrarily defined, the object or system, and it's defined by whatever the discussion is centered around. Or if you have a question about that, it'll tell you what the object or system is. So in this case, our object or our system is this rod here that's negatively charged, and this sphere here that is neutrally charged. The Q is the charge, so -4 is our charge here, and 0 is our charge here. When they contact each other, the electrons from the rod actually jump over. And those charges are going to pass over to the sphere, not all of them, and they're going to be split among those two. So our net charge of this system is -4, and our net charge of this system is still -4. And that's called the conservation of charge. So this is a principle that states that the total charge of a system is fixed. When we touch that negative rod to here, we don't all of a sudden get -10 or get +3 when you add the amount of charge between these two. This is a fancy way of saying that in a closed system, there are a set number of electrons and protons, and they can move around and interact, but they don't just appear or disappear. This is really similar to the conservation of mass, where matter can't just appear or disappear, it can be changed. And the idea applies here. Protons and electrons are physical things, and they can't just disappear or appear. We're going to talk about grounding. This is a very, very useful phenomena that you've probably heard of, but might not understand. I've worked with it and heard of it, and I still don't have a full grasp of it. But at its core, at its simplest form, grounding is just connecting an electrical system to the earth. The idea behind this is the earth is gigantic, and it can donate or accept a lot of electrons. So when you've got I don't know if you guys have ever experienced like a power surge in your home where like the lights flicker or something. If there's a device or a system that has a power surge and there's too many electrons, too much of a current going through that thing, it can get shot into the earth through a grounding wire or a grounding connection. This is useful because it snaps systems back to neutrality, or removes their charge, or sets their charge back to what it should be. This is the reason that birds can land on wires, on like high voltage electrical wires. Generally, when a bird lands on that, they're not touching anything else. So the current from that wire doesn't pass through them and go into the ground. However, if we touch it and we're touching a ladder, that current's going to go through us, through the ladder, and into the ground, causing some damage. The other thing that I think, or the other example that I remember from when I was a kid, was when a power line falls down on top of a vehicle, like a live line falls on top of a vehicle. But I'm going to get you guys to look into that, so I'm not going to explain it here. And conduction versus induction. This is an important pair of concepts. So conduction is transferring a charge through physical contact. So when you touch a negatively charged rod to this charging sphere or neutral sphere, it charges it negatively. And induction is transferring a charge without physical contact. And you guys know this is possible. However, the mechanics of it are a little different, right? Oftentimes we're interacting with electrostatic phenomena. We're making things move or making things kind of jump away without actually touching them. So we know it's possible for electrostatics to interact without touching. We're going to get into how you can charge things like that. Okay, so charging via conduction. Remember, this is one where you're touching. You take a negatively charged object, you touch it to a neutral object, and some of that negative charge, those electrons, are going to pass over to the neutral object, which is now negatively charged. The net charge is a little bit negative. When you take that rod away, this is going to stay negative. Conduction is fairly simple. It's not too bad. Induction is a little weirder. It has kind of an extra step in there. So when we take these two neutral spheres and we bring a positive rod near one of them on the left, all of the electrons are going to be attracted over here, and the protons are going to be repelled over here. And keep in mind, this object still has electrons and protons in it. It's just everything's kind of shifted over to the right. Then we need to remove the connection between those two objects. But this negative rod still has to stay near it because it's still providing the electrical attraction. So we separate those two things, and then we remove the rod, and all of the electrons, the extra electrons, are trapped over here. And this one has a deficiency of electrons now. The one on the right doesn't have as many electrons as it normally does. So it's not neutral anymore, it's positive. And this one has become negative. There's also a second way to do this, and it kind of ties in with grounding. So we can do the same thing. We bring a positive rod near a sphere or another object, and the electrons shift over and the protons kind of shift away. And then we attach it to a ground. And what's going to happen when you attach it to the ground is, like we said, the Earth can donate electrons as well as accept them. A bunch of electrons are going to go up into here and be attracted to the rod. And then you cut the ground, or cut the connection to the ground, and you're going to have an excess of electrons in that sphere. So when you take that rod away, that sphere is still going to be negatively charged. So the idea for both of these methods for charging through induction is you need to basically have a system where you bring a charged object near it. So you get kind of this like polarization, right? You get negatives at one end and positives at one end. And then you cut that system in half, or you cut the connection between those two parts of the system, and you'll be left with one side being, or one part of the system being negative and one part of the system being positive. Okay, the last thing we're going to talk about today is an electroscope. This is less of a phenomena and more of a neat little tool that has been used for a long time to detect electrical charge. And I couldn't find a good short video, so I'm just going to show you with a drawing and a picture. It's going to be beautiful. And you should know how to draw an electroscope and explain how it works or what happens with it. So after I'm done showing you this, I want you to watch the video below for more info and a visual demo. Although you can watch any video on an electroscope really, and you can research an electroscope on your own. They're not too complicated, but the video below has some explanation and shows what happens when you actually bring a charged piece near the electroscope. So let me just change over to our beautiful electroscope. Okay, So our the whole concept of an electroscope, wrong one, is you've got a copper wire or some kind of conductor here, and you've got it running through the top of a uh, jar or some kind of closed system. So these little leaves of aluminum foil won't get affected by wind or anything else. So you got this conductive piece that goes all the way through this tube, and then you've got these two little kind of like leaves hanging off of it. And generally those leaves will hang side by side. They'll hang next to each other. So you've got like one leaf hanging here, one leaf hanging here, and you've got your copper wire running through them. And when you bring your charged object near it, like that, oops, I didn't realize that was on the same layer. Excuse me. When you bring your charged object near the electroscope, then what's going to happen to that copper wire is all of the electrons are going to kind of move up here towards that positive rod, which means you're going to have a positive charge down here. Here, maybe I'll pop open a new layer. So then when you've got our aluminum foil leaves, normally resting like this when they're neutral, if they all of a sudden become positively charged, then those leaves should repel one another. So these leaves will kind of like swing apart almost. And then when you take that away, they'll slowly kind of return to normality as the electrons and the protons disperse once again. That's the idea behind an electroscope. I hope it makes sense. If not, check out a couple of videos, shoot me a message, any of that kind of stuff. And have a good rest of the day. Cheers.